Hi everyone, welcome to our AP Chem tutorial on solving a stoichiometric equation using a BCA table part 2. I'll read the problem to you. The reaction between potassium chlorate and red phosphorus takes place when you strike a match on a matchbox. If you were to react 52.9 grams of potassium chlorate, KClO3, with excess red phosphorus, what mass of tetraphosphorus decaoxide could be produced? So like I mentioned before, our first step is to check if the equation is balanced, and they mentioned that it's unbalanced, so let's get to that first. Okay, 1 potassium, 1 chlorine, 4 phosphorus. Only our oxygens are unbalanced, so I'm going to add the coefficient 10 here. That changes our potassium and chlorine to 10, so I'll add 10 here. And so now we have 30 oxygens here, but still 10 here. So coefficient of 3, that changes our phosphorus to 12, and then we can add a 3 here to make it 12 here. So now it's balanced, so we can get into the actual BCA table work. So 52.9 grams of potassium. Remember, we can't put grams into our BCA table, so let's convert that into moles. 52.9 grams KClO3. I wrote our molar masses here to make it easier for us. That is 122.55 grams per 1 mole of potassium chlorate, and that gets us 0.432 moles of KClO3. We can put that into our BCA table right here because it's a reactant, so we'll put 0.432, and we know that there's excess red phosphorus, so we can just put the word excess right here. We know that our products start off as 0, 2. Since we know this is the excess, we can figure out that this is the limiting reactant. So we're going to use all of it up, and we're left with 0 reactants for KClO3. We don't have to focus on the excess right now, so I'm just going to ignore that. We'll add 0.432 here, gives us 0.432 moles for KCl, and for this one we're adding 0.1296 if I'm correct. Yes, ignoring sig figs for now because we're not finished with everything. So that gives us 0.1296. We're focusing on P4O10, so we can ignore this part, and let's convert this to grams. So that is 0.1296 moles of P4O10, and our molar mass for that is 283.76 grams per mole. And that gives us 36.8 mole. Sorry, did a little mistake here. Put it on the wrong parts. So our mole amount, 1 mole, would go on the bottom, and our molar mass would go on the top. So like I said, this would equal, give me 1 second, 36.8 grams of P4O10, and that's the correct amount of sig figs.